Hello, Earth and Space Science students. This is our first instructional video for week 3 of Unit 3, and this is following the Seismic Explorer activity. So last week what we really talked about was what is kind of inside the Earth, those different layers, and that kind of, I would say, like the vehicle for movement, what makes these plates move on the crust, and that would be convection currents. Now we're going to really talk about what happens when these plates hit each other, and that's really kind of the heart and potatoes of plate tectonics. So in this activity, we're going to learn about different plate movements, what that looks like, and how these different boundaries are created, and how they create some of those different features that we saw in our provocation. You're going to be able to describe evidence of these different plate boundaries, whether that's convergent, divergent, or transform, I think is what it was, the third one, as well as draw some conclusions about how different plate boundaries make different features that we see. So for the lesson plan portion, there's really only two things. There's a video about when Mount St. Helens went off. So volcanoes are one of those different features that are caused a lot from plate tectonics. And so we're kind of doing a lot of volcano stuff as well in this week, just because it's interesting. And then we're going to have some notes on kind of, this is more last week's information about layers of the Earth. So that's what I'm going to go over next. Here is your version. And then as you've done in the past, you'll click the teacher notes, and you're really just copying down what's on this PDF. And that's what I'm going to talk about here really quick. So we have our different layers here on the right. And so we have our solid crust, the solid viscous. Viscous means it can flow. So that's when I said in kind of the videos last week, how the mantle is kind of ooey gooey. This is what I mean by ooey gooey. It can flow a little bit, even though it's technically a solid. We have our liquid outer core and then our solid inner core. And so different characteristics of the crust, it's broken into those different tectonic plates, and we'll kind of look at some of those through some volcanoes in this seismic explorer activity. But these plates are rigid, so it means they're hard. They're not bendy or flowy or anything. And when they interact, they can cause earthquakes, volcanoes, all kinds of different natural disasters that we talk about. For the mantle, because there's uneven heating from the core, so the part near the core is really hot, but then as you get farther towards like the crust end, so away from the core, it gets colder. So because some areas are hotter than others, it creates those convection currents to help kind of make the temperature more even. And that's what causes the movement of the tectonic plates on the crust. In the outer core, it's really, really hot. It's mostly made of that nickel and iron. And then the inner core is our hottest layer, and it's solid due to the pressure. So it could have been a liquid like the outer core, but since there's so much pressure, all that mantle and outer core and crust is kind of pressing on it from gravity and whatnot too. It's a solid, and that heat from that planet formation and radioactive decay. So the reason it's so hot, when you shove a bunch of stuff together, right, that has a lot of energy from when we talked about in the last unit, the accretion theory of things coming together. And then there's also radioactive elements that are decaying in there, and they release a lot of energy when they do that. Just like when we use nuclear fission in nuclear power plants, or breaking things apart, that's kind of what's happening in radioactive decay as well. Some different trends, basically the pressure and the temperature go up as you go down. So they're getting higher as you go farther into Earth. And how do we know this? That's why we're learning about those seismic waves. That kind of gives us an idea of the material and some of the stuff it's made out of. That's kind of what that talks about there. So those are your notes. I'll go through how to do the Seismic Explorer activity in the directions. And have a great day. Bye.